factors are an important data class for representing and working with categorical variables in R. In this lesson, we're going to learn how to create factors and how to manipulate them using the forcats package in Tidyverse. Let's get started. Here's a list of our learning objectives for the lesson. If you like, you can take a second, pause, and read through them, but we're going to come back to them at the end of the lesson. To get started, let's load the packages we will need. So first, we have Pacman that we will use to load in the Tidyverse and here packages. We will be using a dataset containing information about HIV mortality in Colombia, which is hosted in the open data platform Datos Abiertos Colombia. And if you would like to learn more, you can access the full dataset in this hyperlink. So if we load in our dataset, you can see that each row corresponds to an individual who passed away from AIDS or AIDS-related complications. Now, we have a number of variables. However, if you would like to have more information, you can see the appendix at the bottom of your lesson notes for a data dictionary describing all variables. So moving forward, let's discuss what are factors. Well, as we said, factors are an important data class in R used to represent categorical variables. And well, as a refresher, categorical variables take on a limited set of possible values or levels. For example, country, race, or political affiliation. Now, these differ from free-form string variables that take arbitrary values, and these can be person names or book titles, or even doctor comments. And now, factors have a few key advantages over character vectors for working with categorical data in R, mostly in that factors are stored in R slightly more efficient than characters. Certain statistical functions, such as LM, require categorical variables to be input as factors. And lastly, factors allow for control over the order of categories or levels. Now, this allows properly sorting and plotting of categorical data. And now this last point, controlling the order of factor levels, will be our primary focus in this lesson. Let's see a practical example of the value of factors using the dataset we just loaded above. Suppose that you're interested in visualizing the patients in the dataset by their birth month. So we can do this with the following ggplot code. And if we run this code chunk, we get the following output. Now, if you look closely, you'll notice that there's a problem. The x-axis, which represents the months, are arranged alphabetically, with April 1st on the left, followed by August, December, and so on. But, as we all know, months should follow a specific chronological order. Well, to fix this, we can arrange the plot in the desired order by creating a factor using the factor function with this code. So combined with the mutate function, the syntax for the factor function is quite straightforward. The x argument, as seen here, takes the original character column, which in our case is birth month, and the levels argument takes in the desired sequence of months. So we can shorten that to January, February, and so on and so forth. Now, if we run this code chunk and we inspect the data type of the birth month variable, we can see its transformation. So if we input the modified dataset, modified, and compare it with the original dataset, we can see that the modified dataset variable has been changed to a factor from its original character form. Now, we can regenerate the ggplot with the modified dataset. So if we input the modified dataset, into the ggplot code. We will get the following output. Now, as we see, the months on the x-axis are now displayed in the order we specified. Furthermore, the new factor variable will also respect the defined order in other contexts as well. For example, let's see and compare how the count function displays the two frequency tables as we see below. We can see that the original dataset, which had the birth month as a character variable originally, months are listed in an alphabetical order with April 1st, followed by August, December, February, so on and so forth. However, when we compare it with a modified dataset, wherein we created a factor variable in birth month, you can see that the months are now listed in their original, as intended, chronological order of January, February, March, April, May, June, so on and so forth. At this time, let's take the opportunity to review and practice. On your screen, read the following questions and ensure that you understand what is being asked. Take a moment and think about your answer. Now, functions are very useful, but they can be sometimes a little tedious to manipulate using base R functions alone. Thankfully, the forcats package, which is a member of the Tidyverse suite, offers a set of functions that make factor manipulation much simpler. Here in this lesson, we'll consider for function, but there are many others, so we encourage you to explore the forcats website on your own time, and you can also access it within this hyperlink here. Now, first off, the factor or FCT relevel function is used to manually change the order of factor levels. For example, let's say we want to visualize the frequency of individuals in our dataset by municipality type. Well, when we create a bar plot using this ggplot code, the values are ordered alphabetically once again by default. So we have municipal head followed by populated center and scattered rural. But what if we want a specific value, say populated center, to appear first in the plot? Well, this can be achieved using the factor relevel function once again. So within the mutate function, we are going to indicate factor relevel. And the syntax is quite straightforward. We're going to pass the factor variable as the first argument, so municipality type. And then the level we want to move to the front is going to be our second argument. In this case, we said we wanted populated center to appear in the front of the plot. So once we do that, now we can replace the following and create another plot. So here we can see that the populated center level is now first. Now similarly, we can also move the populated center level to a different position with the after argument. Now, we can do this by doing the following. So within the factor relevel function, the syntax is quite simple. So first, we're going to specify the factor, which is municipality type, and then the level to move, which is populated center, and then we're going to use the after argument to define what position to place it after. In this case, we're going to use 2. So once we do that, we're going to pipe it directly into a plot in order to visualize the change. Here we can see that populated center has now been moved to the last, and it's after the 2 bars we have specified, which is municipal head and scattered rural. Now furthermore, We can also move multiple levels at a time by providing these levels to the factor relevel function. So here in the code chunk below, we're going to rearrange all the factor levels for municipality type in our desired order. So let's say we're going to choose scattered rural to show first, followed by populated center, and last but not least, municipal head. And then once again, we're going to pipe it into a plot for viewing purposes. And here we can see that we have successfully rearranged the multiple levels at the same time by predefining them within the factor relevel function. You may have noticed that this is similar to creating a factor from scratch with levels in that order. Now, instead of the factor relevel function that we have been going over, we're simply going to use the factor function as we observed in the beginning of the lesson when we were creating factors from scratch. So once again, within the mutate function, we're going to feed in the factor function, specifying the factor, which is municipality type, and then specifying the levels again in which we want the factors to show up. So in reference to the image that we just created, we're going to go ahead and copy these orders and paste it into these levels here. Now it's time for another small practice question. On your screen, read, take a moment, and indicate your answer in your own RStudio window. Now another function within the forcats package is the factor reorder function, which is used to reorder the levels of a factor based on the values of another variable. So to illustrate, we can make a summary table with the number of deaths, mean and median age at death for each municipality. Now when we run this code chunk, we see that for Aguadas, we have 2 deceased with a mean age at death of 42 and a median age at death of also 42. And we can continue to see that for all municipality names within Colombia. However, when plotting the variables, we might want to arrange the factor levels by that numeric variable. For example, to order municipality by the mean age column is seen here, we can indicate within the factor reorder function the municipality name as the first argument. And in the second argument, we're going to indicate the numeric vector determining the new order. And as we said, we want to arrange it by the mean age at death. Now we can plot a nicely arranged bar chart. And once we run our ggplot code with municipality name as a y-axis and the mean age at death as our x-axis, you can see that the municipalities are now in order from the highest mean age at death to the lowest age at death. From Marolanda with the highest to Norcasia with the lowest at around 25 years old at the age of death. For now, it's time for a little mini practice question. Please take a moment to read and answer. Sometimes we want to arrange the categories in our plot to appear in a specific order that is determined by a summary statistic. For example, let's consider a box plot of birth year by marital status. Now here we see in the box plot, it's displaying the median birth year for each category of marital status as a line in the middle of each box, as seen here. So widowed, single, separated, divorced, and so on and so forth. Now, we might want to arrange the marital status categories in order of these medians that are indicated by the lines. But if we create a summary table with the medians like we did before, we cannot create a box plot with it. Now, feel free to go look at the summary per Muni data frame to verify this yourself. You can scroll up above and look at it. However, to solve this issue, this is where the point fun argument of the factor reorder function comes in. Now, the fun argument allows us to specify a summary function that will be used to calculate the new order of the levels. Now, within this code, in this code chunk, we have the two arguments that we previously have gone over. So f and x, which indicate the factor to reorder, and then x indicates the numeric vector determining the new order. So in this case, we want it ordered by birth year. So here we also added the fun argument to specify, once again, a summary function to calculate the new order of levels. Here we want it by median. And we also included the NA remove argument to ignore NA values when calculating the median. So setting it to true will ignore NA values when calculating, once again, the median for this. Now, when we create our box plot, we can see that the marital status categories have been ordered by the median birth year. And we can also observe that the individuals with the marital status cohabiting tend to be the youngest since they were born in the later years, around 1975. And those who are widowed tend to be the oldest, with a median birth year of around the late 1950s. Now here is a little fun question using the point fun argument. So take a moment to read the question on your screen and answer. And now another useful function within the forcats package is factor recode. Now this function allows us to manually change the values of factor levels. And this function can be especially useful when you need to rename categories or when you want to merge multiple categories into one. For example, if we want, we can rename municipal city head to city within the municipality type variable. So within the code that you see here, in the factor recode function, we're going to indicate first the factor variable you want to change, which is municipality type. And now in the second argument, as you can see here, we're going to indicate the set of name value pairs that define the recoding. So in the left side of the equal sign, we're going to input the new level, in our case, city. And on the right side, we're going to input the old level, which is municipal head. And when we run this chunk, we can see the levels and we can confirm that the new level, city, has been renamed from municipal head. And the other levels, populated center and scattered rural, remain the same. Now, the factor recode is also particularly useful for compressing multiple categories into fewer levels. And we can explore this using the education variable. And if we run this code chunk, we can see that it currently has 6 categories, which are no information, none, post-secondary, preschool, primary, and secondary. Now, if for simplicity, we want to group them into just 3 categories, primary and below, secondary and above, and other, we can do so with the following codes. So it's the same theory that we applied in the code up here. We're going to first indicate the factor variable, which we want to manipulate. And on the left-hand side is a new name for the level, which is primary and below. And the old name is primary. And we continue to do that for all 6 levels. And now when we run that, we can confirm with the count function that the categories have indeed been condensed nicely from 6 to now 3 categories. Now for good measure, we may want to arrange the levels in a reasonable order with others as the last level. Because as you can see up here, others currently shows first. So to do that, once again within the factor relevel function, we're going to indicate the variable that we want to manipulate. And now we input the levels in the order that we would like them to appear. So once we run that code chunk, and we also run this count function, we can now confirm that others appears as the last level compared with the original table here where others was appearing first. Now let's take another moment to practice the factor recode function using the HIV more dataset. Take a moment to read and answer. Now, sometimes we have too many levels for a display table or plot, and we may want to lump the least frequent levels into a single category that we typically call other. Now, this is where the convenience function factor lump comes in. In the example, let's pretend that we want to lump less frequent municipalities into other and preserve just the top 5 most frequent municipalities. And we can do that with the following code as seen here. So within factor lump, we're going to indicate the variable that we want to change. Here it's municipality name. And here we're going to input a second argument specifying n equals 5. Now, in the usage here above, the parameter n equals 5 means that the 5 most frequent municipalities are preserved and the rest are lumped into other. And so once we run this code chunk that also contains our ggplot code, we can confirm that the municipalities have been lumped into the top 5 most frequent municipalities as seen here. And the other municipalities have been lumped into this other category as you see in this part of the visualization. Now, for the sake of clarity, we can also provide a custom name for the other category with the other level argument. Now, here below, we use the same code as we saw up above with the factor lump function. However, we just add another argument, which is other level. And here, you can see that we specify the other level to be named other municipalities. So once we run this code chunk, we can now confirm that the other category that we see up above here has now been renamed to other municipalities, which specifies that now this level comprises other municipalities that were not within the 5 most frequent municipalities. In this way, you see that the factor relump function is a handy tool for condensing factors that have many infrequent levels into a more manageable number of categories. Now, on your screen, you're going to see that it's time for another practice question, this time using the factor lump function with, once again, our HIV mort dataset. Take a moment to read and answer. And that actually brings us to the end of our lesson. For now, let's take a look at the learning objectives and see if you've understood them. So the point is that by the end of this lesson, you understand what factors are and how they differ from characters. The second point is that you are able to modify the order of factor levels. And the last point is that you're able to modify the value of factor levels. Now, in summary, you learned about the data class factors and how to manipulate them using common operations like factor relevel, reorder, recode, and lump. Now, while these covered some basic operations such as reordering and collapsing levels, this only scratches the surface of what's possible with the forcats package. But since you understand the basics of working with factors, you are more than equipped to properly represent your categorical data for downstream analysis and visualization in R. For more information, we do encourage you to check out the forcats website for an in-depth look at the additional functions that the package contains. Thank you for listening and see you in the next lesson.